Hello, my name is Yaren, and I'm studying at Bilkent University, Electronics Engineering. And today I'm going to conduct an experiment, and my aim is observing the kinetic and static coefficient of friction. And I need a scale, a scientific ruler, different objects, a spring, a goniometer, an inclined plane. And to be ensured that the platform is not inclined, I need a water gauge. In the first part of my experiment, I will calculate the spring constant, and so I will measure the weight of this object. Now I will look to the compression of the spring. Now I can calculate the spring constant. In the second part of my experiment, I will calculate the coefficient of kinetic friction. So knowing the spring constant, I will compress the spring, and so that when the object is released, it will be transferred to the kinetic energy. And when the object stops, the kinetic energy will be dissipated by the kinetic friction. So I'm compressing, and now I will measure the compression again. Yes, now the energy is stored in the spring, so I will release. Yes. Now the energy is dissipated by the kinetic friction, so I can calculate the coefficient of kinetic friction. In the last part of my experiment, I would like to calculate the coefficient of static friction. So I use a tilt platform and having the same surface which I used in my second part of experiment in order to compare the static and kinetic coefficients of friction. Now I will make the surface and platform up, and in the critical angle that I'm measuring now, the net force will be 0, which means mg sine theta will be equal to the static friction. So I can easily calculate the coefficient of static friction in that way. Now it's sliced, and I will make a note of this angle. We measured the coefficient of static and kinetic friction separately for the same surface to compare, and we get the result that the coefficient of static friction is always greater than the coefficient of kinetic friction.